This lesson is all about how in different states of matter, solid, liquid, gas, and plasma, substances can change from one state to another. The other word for that is a phase change. So solids can become liquids, liquids can become gases, and everything in between, how things can change. I think that these notes go on page 43. If it's not 43, it's 41, but I'm pretty sure you have notes on 41. So make these notes on page 43. And you might want to leave the paper kind of open and draw these notes as a diagram. As we go along, you might want to do it as a diagram rather than setting it up Cornell style. But it's kind of up to you. You can pause the video at any time and change how you're doing your notes. Now let's start with a solid. We can just talk about a solid first of all. A solid, remember, the particles are tightly packed, like in this little drawing, and they're jiggling in place. An example given here is, it looks like an ice cube. Now if you add heat to a solid, we call that melting, and the solid becomes a liquid. Okay, so you add heat to a solid, it becomes a liquid. That process is called melting. Now when that happens, though, what happens to the particles is they begin moving faster because you're adding heat. They begin moving faster and faster and faster, and they move so fast that they begin to spread out. They have more room to move, and they begin sliding past each other, and that's, of course, what we call a liquid. Now if you continue to add heat, more and more heat to a liquid, the particles move even faster and faster and faster and faster and faster, and they undergo this process we call vaporizing, or it's also called evaporation. My pen's too large, but it's called evaporation. We also sometimes might call that boiling, but in that case the particles begin to move so fast that they escape out of the container that they're held in, and they become a gas. And the particles are spread way far apart, and they're zooming at very, very high speed in a gas. So these are two processes, melting and evaporation, or melting and vaporizing. And you have changes from a solid ice to a liquid water to a gas water vapor. Now if we just look at the process of a solid becoming a liquid, or a liquid becoming a solid, we can find that those two events happen at the same temperature, 32 degrees Fahrenheit or 0 degrees Celsius. So if you add heat, you have melting, solid becoming liquid. If you take away heat, you have freezing, a liquid becoming a solid. We can also look at the process of evaporation, where we added heat to make water become steam or water vapor. The exact same process in reverse we call condensation, and that's where a gas becomes a liquid, and again you're taking away heat. Okay, so on this side it's cooling. In other words, you're taking away heat, and on the other side it's a warming process because you're adding in heat. These also have a very specific name that we could use. If it's a cooling process, it is called exothermic. Okay, exo meaning out, thermic meaning heat. Heat goes out, so it cools down. The opposite, the warming process, is called endothermic. I'm going to run out of space here. Endothermic, because you have to put heat in. Endo means in. You have to put heat in, and it's a warming process. Not to change the subject, but I hope you all had a great Thanksgiving, and that you enjoyed a nice big piece of pumpkin pie. I just had one myself a moment ago. So another way to think about this is to just think about these couple of points, the freezing point and the boiling point, and the temperature, low to high. At a very low temperature, we have a solid. No matter what the matter is, we can talk about water because that's easier, but any kind of matter, including oxygen, which is bizarre, or nitrogen gas, or helium even, at a low enough temperature, it will be a solid. As the temperature increases, we have a freezing point. At the freezing point, also known as the melting point, the exact same temperature as the melting point, it becomes a liquid. It is a liquid for a long temperature, different depending on what substance you have, but eventually you'll reach something called the boiling point. It's also the condensation point, and at that point it will become a gas. Now, this isn't the whole story though, because you can also have a change in phase, a change in state from a gas directly to a solid. You can also go from a solid directly to a gas. If you're going from a solid directly to a gas, that is called sublimation. You may have seen an example of this before, and that is dry ice. So you have a solid chunk of a compound called carbon dioxide, which you've heard about before. Carbon dioxide, but it's so cold it's a solid. When you expose it to the air, rather than melting, it goes directly to a gas. And that's what you see in this picture here. You see a little solid chunk of carbon dioxide there, and then of course the gas carbon dioxide coming off of it. As I said before, you can also go from a gas directly to a solid if the temperature is right and the substance is right. This process is called deposition. Deposition. Deposition, as in making a deposit, and it's a deposit of gas as a solid. An example of deposition is frost, like on these trees. During the night, the temperature drops and the water vapor that's in the air is deposited onto the tree as a solid ice rather than as a liquid. If it warms up, it becomes a liquid, or if it is not as cold, then it's a liquid, and we call that dew. We have dew here in Florida. We don't have frost very often, but in colder climates, when the temperature drops at night, instead of the gas, water vapor in the air becoming a liquid on the trees, it actually becomes a solid because it's so cold. So here's an overview of everything we've just talked about, and this is a good way to write it in your notes if you wanted to, but if you write it a different way, that's okay too, whatever works for you. If you're a visual learner, this really helps. But we have our three states of matter. We have gas, we have liquid, and we have solid. And each state can transform into the other. We can go from a solid to a liquid, that's melting. We can go from a liquid to a solid, that's freezing. We can go from a liquid to a gas, that's evaporation. We can go from a gas to a liquid, that's condensation. We can go from a solid to a gas directly without becoming a liquid, and that's called sublimation. And we can go from a gas to a solid directly without going through a liquid, and that's called deposition. Okay, you got it? If you have any questions, bring them to class. We're going to have one more thing I want to talk to you about, and then I'll be done with you for this lesson. Did you guys get cold over the break? Oh my goodness, it's been so cold. Here's a little funny for you to humor things up a little bit. Okay, the last thing I want to talk to you about is how energy changes as temperature changes and the state changes. And this is a graph showing as temperature changes over time. Okay, so you're heating up a solid here at A. During the time that the solid is heating up, it just gets higher and higher in temperature. At some point at B here, it begins to melt. And I want you to notice that the graph stays flat during this time. So I want you to understand that while a substance is melting, also while a substance is freezing, that there is no change in temperature. It stays right at this case, 0 degrees Celsius, because it's talking about water. Then, once it's completely melted, and now it's a liquid at C, the temperature is going to increase again until it reaches a certain point, and that point is vaporization or evaporation. So the temperature begins to increase while it's a liquid till it reaches approximately 100 degrees Celsius if it's water, And then once again, I want you to notice at D that there is no change in temperature during this time. It's a flat graph, and that means that energy is still being given in, heat is still being added, but during the time that the liquid is evaporating, there is no change in temperature. And then at a certain point, when all of it has vaporized, now it's a gas, completely a gas, and the temperature will increase again. It will keep on going up. But what's happening at B and at D is called latent heat. Heat is being added, but the temperature is not changing during that time. Energy is going, sort of, you can think of it as going into the molecules to make them move faster, but temperature isn't increasing during that time. And we'll talk more about this graph in class, because I'm assuming you're gonna probably have some questions. So that's it for this lesson, and I really, once again, hope you had a happy Thanksgiving. Hope you enjoy the rest of your break. And if you're watching this after we're back to school, I'm sorry that break is over. I had a great Thanksgiving, and I'll see you in class.
Made with Doodlecast Pro.